Okay, let's continue. How many moles are in 1.20 times 10 to the 25 atoms of phosphorus? So in this case, we are given atoms and we are trying to find moles. So in our T table, we're going to start with 1.20 times 10 to the 25th atoms of phosphorus. We're going to use our brand new conversion factors and say that 6.02 times 10 to the 23rd, our particle here is atoms of phosphorus. That goes on bottom this time. And on top, that would equate to 1 mole of phosphorus. Feel free to pause and calculate to practice. The answer that we get is 19.9 moles of phosphorus. How many atoms are in 0.750 moles of zinc? So here we have moles, we're trying to find atoms. So we'll set up a T table and say 0.750 moles of zinc. On our roadmap, we're going from moles into representative particles, so we're going to put 1 mole of zinc on the bottom, and 6.02 times 10 to the 23rd atoms. That's our representative particle. Feel free to hit the pause button and calculate. The answer is 4.52 times 10 to the 23rd atoms of zinc. Next question, how many molecules are in 0.092 moles of CO? So our representative particle is changing. I'm going to set up a T table. We're going from moles into molecules. 0.092 moles of CO. For every 1 mole of CO, we're going to go on top and say 6.02 times 10 to the 23rd molecules of CO. That's carbon monoxide. Hit the pause button to check your work. After calculating, the answer will be, looks like we'll have to come back and fix this video and get the answer. I do not have it. Next question, how many moles are in 9.67 times 10 to the 24th formula units of NaCl? Formula units, because sodium chloride is a ionic compound. 9.67 times 10 to the 24th, careful now, formula units of NaCl. We're going to put formula units on the bottom, which means Avogadro's number has to be on bottom. 6.02 times 10 to the 23rd formula units of NaCl is equating to 1 mole of NaCl. Hit the pause button, check your work. If you're getting the wrong answer, I advise you to put parentheses around your scientific notation numbers. And it also appears that we need an answer for this one. We will come back and fix this later. I apologize. Next, we're going to change our conversion factor. We're going to look at volume and mass, our last two out of the 3 conversions. So let's talk about volume and mass. So particles come in different masses and sizes. Therefore, just because we have 1 mole of a substance, that does not mean that we have the same mass or the same volume. It does mean we have the same particles, though. So look at the image below. If we have a mole of each of these substances, take a look. Copper looks like it has the smallest amount, probably because it's the heaviest substance or most dense. A mole of aluminum takes up more space. And then a mole of salt and a mole of sugar. It's clear that sugar takes up way more mass and space because it's a larger molecule. And a mole of water, okay, it's a liquid. We can still measure volume and mass of that liquid. So if we're talking about something called mass, we use a phrase called molar mass. See it there? We're taking into account the relative amount of moles in every given amount of mass. So let's define molar mass together. Molar mass is the mass if we had 1 mole of atoms, molecules, or formula units. So if we scooped up 6.02 times 10 to the 23rd atoms, molecules, or formula units, put it on a scale, we would get what we call molar mass. And it just so happens that the atomic mass of every element on the periodic table is the molar mass. So let's take carbon, for example. If we find carbon on our periodic tables, you might want to grab one. It's 12.011 grams. So if we were to scoop up a mole of carbon, put it on a scale, it would weigh 12.011 grams of carbon. Take copper, for example. If we scooped up 6.02 times 10 to the 23rd atoms of copper, put it on a scale, it would weigh 63.546 grams of copper. So, long story short, we're going to say 1 mole equals the periodic table mass. That's our newest conversion factor. So let's find the molar mass of these elements. Take your periodic tables. Feel free to hit the pause button before you do these. What is the molar mass of these elements? If we take magnesium, we'll find on the periodic table that it is 24.3 grams per mole. If we look at chlorine, we'll find 35.5 grams per mole. Barium, 137.3 grams per mole. And carbon, 12.01 grams per mole. Look at the units. Grams per mole. That's like saying 24.3 grams if we had 1 mole. So, we will be representing molar masses as grams per mole for the rest of the year. This is very important. So, let's use molar mass in order to convert into moles or out of moles. Find this example in your notes. How many moles are in 51.00 grams of magnesium? So I'm going to start my T-table with 51.00 grams of magnesium, and I'm going to use my newest conversion factor, molar mass. The mass of magnesium on the periodic table is 24.31 grams, and that's going to be for 1 mole. So grams will cancel, we'll be left with moles. Pause if you want to check your work first. The answer is 2.098 moles of magnesium. How many grams are in 1.10 mole of platinum, PT? I'm going to start with moles on top this time, 1.10 moles of platinum. And in this case, our molar mass is going to flip. So in this case, I'm going to say 1 mole of platinum on the bottom equates to 195.08 grams of platinum. That's the periodic table atomic mass. Pause if you want to check. The answer here is 215 grams of platinum. Now, here's a big step. What if we have a compound? Which means, what if we have something that doesn't have just one element, it has multiple elements? Well, we're going to have to do something where we're going to add up all of the masses of all of the atoms and get a total. So this is a summation we're about to complete. Step 1, find the molar masses of each element inside the compound. Then we're going to have to multiply all of the molar masses by the number of each element in the compound. And last but not least, I said it was a summation. We're going to add all of the molar masses together to get the total, what we call molecular mass or formula mass. So let's take an example like sulfuric acid, H2SO4. It's in car batteries. We have 2 hydrogens in this formula, 1 sulfur, and 4 oxygens, denoted by the subscripts in the formula. So let's look. We're going to have 1 hydrogen here that's a mass of 1.008, but we're going to have to multiply that by 2 because there's 2 of them. So that's what we do here. We take 2 and we're going to multiply it by the mass of hydrogen. Sulfur, there's just 1. And then oxygen, there's 4. So you'll notice we have a 4 multiplying by 16 there. And what we're going to get is a total. In this case, 98.1 grams per mole. So let's practice doing that together. First one, what is the mass of PCl3? It looks like we have phosphorus trichloride. It's a molecular compound. We have 1 phosphorus atom. And the phosphorus has 31.0 grams per mole on the periodic table. Chlorine has 35.5 grams per mole. Now, here's the deal. There's 1 phosphorus and 3 chlorines. So I'm going to multiply phosphorus by 1, and I'm going to multiply the chlorine by 3. When I do that, I get 2 different answers here. 31 stays, and 107 is our mass for all 3 chlorines. To get the molar mass, we're going to add those 2 numbers together for a total of 138 grams per mole. Feel free to pause and try the next 2 on your own. The molar mass of calcium nitride is an ionic compound. so we would call this gram formula mass. The mass of calcium is 40.1 and the mass of nitrogen is 14.0 from the periodic table. There are 3 calciums and 2 nitrogens. We multiply them together to get 2 more numbers, which we are going to add together to get 148 grams per mole. Last one. This is called methanol, CH3OH. Carbon is 12, hydrogen is 1.0, and oxygen is 16.0. If we count the atoms, we have 1 carbon, 4 hydrogens, be careful there, and 1 oxygen. We multiply and get 12, 4, and 16 respectively, and we are going to add these 3 numbers together to get 32.0 grams per mole. Feel free to pause if you need to catch up there. Okay, let's get a little more complex. Hit the pause button. Practice these on your own. Okay, hopefully you've completed these. Let's check our work. Magnesium, phosphorus, and oxygen. Those are our 3 elements. Careful here. Magnesium, there are 3. How many phosphorus are there? That 2 on the outside distributes. So we have 2 phosphorus inside the parentheses. And then oxygens, we have to have 4 2 times. The 2 distribute. So that's 8. We have 8 oxygens. Multiply, get 72, 62, 168 respectively. Add them together. Our total molar mass is 263 grams per mole. Okay, last but not least, ammonium sulfate is the name of this compound. We have nitrogen, hydrogen, sulfur, and oxygen. Wow, 4 elements. Goodness. So we're going to take the molar masses on the periodic table and multiply them. Nitrogen has 2. Hydrogen has 8. Sulfur has 1. Oxygen has 4. We're going to multiply those out. 28, 8, 32, and 64. And when we add those together, we get our molar mass of 132.1 grams per mole. Last but not least, you're free to try to work this problem out, but there is a TEKS checkpoint in the slides. Feel free to check that out if you want one additional practice problem. Great work today.